Good afternoon, everyone, and welcome back to the Faculty Development Program. Myself, Ishan Upadhyay, would like to extend a very warm welcome to the fourth day of the FDP on modern educational tools and pedagogical practices for online teaching organized by Vidyalankar Institute of Technology. Till now, we have upgraded ourselves very well with interactive teaching using MATLAB in yesterday's session. Now it's time to get deeper and understand leveraging hardware and IoT to facilitate online teaching using MATLAB Simulink. So, to give you all a hands-on session for programming a MATLAB, we have with us today afternoon our speakers from educational team of MathWorks India. Our first speaker is Ms. Naini Dawar. She is an educational technical evangelist at MathWorks India. She works with universities and educational institutes on adoption of MATLAB and Simulink in research and curriculum in the areas of power electronics and control design. She has around 4 years of experience of working with industry and another 3 years with academia. Prior to joining MathWorks, Ms. Naini has worked as a senior engineer in R&D in an automotive company where she has worked on model-based designing and autocode generation and integration using MATLAB and Simulink. Ms. Naini holds a bachelor's degree in electronics and communication from Kurukshetra University and master's degree in electronics and communication from Chitkara University, Punjab. I extend a warm welcome to you, madam. And along with Ms. Naini, we also have with us our speaker from yesterday's session, Mr. Dev Singhdev. He has already given us very engaging session yesterday and told us a lot about MATLAB and Simulink. So we are happy to have him with us again in our studio. Welcome, sir. Once again, on behalf of Vidyalankar family, I extend a very warm welcome to all our speakers. Without any further delay, I request our speakers to address our delegate. Thank you.
Hi, good afternoon, everyone. Okay. Hi, good afternoon, everyone. This is Naini. I'm from the education technical team at MathWorks. So as already introduced by Ishan, I work as education technical evangelist, and as a tech evangelist, what we are involved in responsibilities of adoption of MATLAB and Simulink in curriculum and research. For today's session, I'll just start sharing the screen. Just give me a second. I'll start sharing the screen and I'll show you what we are planning to discuss today. So I hope my screen is visible to everyone. I would request the host to kindly let me know if my screen is visible. Thank you so much. So I'll get started with the session. So the session today is on leveraging hardware and IoT to facilitate online teaching using MATLAB and Simulink. I'll try to go slow because it's about hardware integration as well. Since we cannot do the hardware demos and show it directly during the webinar at times, so what we have done is we have recorded some videos that I'll be showcasing. In between, I'll keep taking a pause to check with the host if my audio and the screen is visible. Along with me in the webinar today is Deb. Deb, he's from the Education Technical Evangelist team at MathWorks again, and he's based out in Pune office. Along with us, we have Nikhil. He's from the Engineering Development team, and he's based out in Hyderabad office. So myself from the Tech Evangelist team, I'm based out in Bangalore office. So I'll start sharing the slide sorter view, and let's get started. So I'll try to take it a little slow to understand if the slides are being updated at your end properly, because I can't see the chat window at my end. But again, I'll take a pause in between and I'll check with the host if everything is visible, right? So why are we here today? And as you all know that we are moving on to an online mode of engagement, and another component which was or which is and which always will be very important for academia is experiential learning, where the students are trying to work not only on the equations or the mathematical part or just the theoretical concepts, but they also want to understand the real-time implementation of those problems, right? And they also want to understand how their subjects or whatever they are studying in their curriculum is linked with the real-time applications. We always make use of hardware to make them understand these concepts. And now, as we are moving on to an online mode of education, we'll learn today how we can use that online mode of education along with the hardware to make the flow of experiential learning continued and make that particular learning phase continued in academia. Another thing is the project-based learning or the problem-based learning, again, where the students are focused not only on a specific domain, but they also try to understand the multidisciplinary nature of an application, and they try to integrate it with other hardware so that they can also understand the real-time application of that. So let's get started and let's just see what are we going to achieve today first. So before with that, let's just see what the technical computation workflow is. Because we say, as you already have attended yesterday's webinar from Dave and Praful, they might have mentioned that MATLAB is a technical computational tool. So, but what a technical computation workflow looks like. So whenever, if you are making an application or if you are making a project, if you have a problem statement, you always start by accessing the data. So you have the data first. Now that particular data can be in the form of a document. Those can be the textual data in the form of files, or it can be the signals coming from a software, or you might also be integrating your project or your application with a hardware or a sensor from where you are acquiring the real-time data, right? So the first step of making any sort of application is the data. So you have to access that data. Once you have it, before you start building an algorithm on that, you firstly have to analyze and model it. You have to understand how your data looks like. What is the pattern in that data? Once you have seen that, once you have analyzed that data, that's where you start working on the algorithmic development for that, right? Then once you are making an algorithm, you actually make an application out of it. Now there's no point of making such applications if you cannot share it with the outside world. So that's where the third step in the technical computation workflow comes, is the sharing part, where we are trying to share whatever application we make. Now that sharing can be either in the form of a documentation, or it can be some hardware project, or it can also be an executable file which is shared with another group or another colleague of yours who will start working on top of it if you are working on a collaborative project, right? So, but this thing doesn't end here. What you also have to do is you have to automate the process. So by automation mean you don't want to keep accessing the data manually all the time. You want to actually automate that process. So this is how the technical computation workflow looks like. And MATLAB as a high level language, it's used for all these four steps: accessing, exploring and discovering, and sharing the data, and last but not the least, automating the entire process as well. Right? That's why MATLAB is called as a technical computational tool. Now, if we see, now this is a short video. Now in this video, what you can see is what we can achieve today, right? And how students can also make such very basic fundamental applications using MATLAB and Simulink, and not just using the tool, but also the online version of the tool. So that's where the online education comes into picture. So if you see this particular video, now this video is being captured on an Android device, and that Android device, what I'm trying to do is I'm capturing the screen. So I'm doing the screen recording. What I'm trying to make here is an image inversion application. So what is happening is, I'm now in this particular example, I won't be focusing on a specific domain like electronics and communication, mechanical, or computer science. So these sort of applications might be used in all sorts of domains. So if you see in this one, the image inversion, what we have is whatever is being captured, that image is being inverted, right? So if I play the video, now this video is being taken from my office, and this is my desk, and this is my laptop and the monitor screen, which I'm missing quite a lot right now. I don't have access to all of these things. I just have the access to my own laptop, right? So this is how the application is being built on Android, and this has been built with MATLAB and Simulink. This is what we will learn today in this webinar, how to make such applications, right? So to get started, briefly, what MATLAB is. So MATLAB is a high-level language. MATLAB is an interactive development environment. You might have seen that yesterday as well, when you might have come across the live script or the MATLAB app designer. So it's an interactive development environment where it's not always needed to have the knowledge of coding. You also might want to interact with the controls or the UI, and then on the basis of that, make applications. MATLAB is used for different sorts of applications like numerical computation, data analysis, and visualization, making algorithm for sure, and then not just making the application, but also doing the application deployment. Now that application deployment either can be in the form of a hardware, or it can be a standalone application also, right? So today, you might have already seen what MATLAB is yesterday and how you can use it for interactive teaching. Today, what we'll also try to focus slightly more on is what Simulink is. So what you see on the right-hand side is a graphical view of some sort of application. Now, what Simulink is, so Simulink is a block diagram environment. It has the built-in library blocks. So as you can see, these blocks on the right-hand side have been dragged and dropped from a built-in library browser. What you can do with Simulink is you can model and simulate and validate the dynamic systems. So all the industries, be it the automotive, aerospace, when they talk about making their algorithms or the applications, if they talk about deployment or the production deployment as well, that's where they use Simulink along with the term or along with the approach called as model-based design. But how we want to bring that in academia is like if this particular student or a group of students is making a project, they must have the knowledge of the entire system. Now, systems are always dynamic in nature. So it always, the inputs change with time. You have to analyze what's the impact of changing that input on the output. So that's where the dynamic nature of a system comes into picture. And that's where Simulink is useful. Simulink has different visualization blocks. One of the visualization blocks you can see here. So what you see in this one is a power window, which is being simulated. And this has been taken as a screenshot from one of the visualization blocks. Automatic code generation. So even if you don't have the domain knowledge, or if you don't have basically the knowledge of coding, if you don't feel like you're a pro in coding, but you want to make certain applications, that's where, so coding is not the only requirement. The only thing is you should be able to build the logic, right? So that logic building can be done using a block diagram approach as well. And what happens with Simulink is, so Simulink gives you the capability, or it has the ability to automatically generate the code. Now that is C++ code, and that can be deployed to the hardware. It's used in multiple sorts of applications: control systems, signal processing, communication, mechanical systems, and last but not the least, all sorts of dynamic systems. You can make use of Simulink for such applications. Briefly, I'll give a product overview. So MATLAB is a base tool. Along with MATLAB, what other tools are used is math stats optimization, application deployment you can do, database accessing. On top of it is Simulink, which is basically a block diagram approach and is used for model-based design in industry. And we also try to bring Simulink as a system thinking tool in academia. What Simulink comes along with is different other tools like physical modeling, event-based modeling. Now these sorts of modeling, so this is for the modeling and simulation approach, right? Now the different application areas are control systems, signal processing, image processing, as I already mentioned, right? So this is the entire MathWorks product family, and there are multiple other tools which are linked with each other in this case. I'll move ahead. Now, what I plan to do is, since I said I showed the video of an image inversion, now what we are planning to do in this case is we have here a picture of papers, right? What we want to do is we want to invert that image. Now, the ones who are using MATLAB already, you might be aware of this thing that you might have seen this papers image already in the MATLAB documentation or as a part of the tool, and you can invert it using the algorithm. But how we can take it to the hardware, that's what our entire webinar is all about. So what we'll do is we'll take this to Android for now, and then we'll discuss about Arduino and the IoT applications also, right? So for this case, I will switch to the tool. Rather than spending time on the slides, I'll directly go to the tool, MATLAB. Before I switch to the tool, I'll just quickly open and check if my audio and screen is fine. Can anyone from the host team please let me know if everything is fine so far? Sure, thank you. So I'll just quickly jump to the tool. So this is MATLAB 2020. This is the new version of MATLAB, the latest version. You might have seen this already yesterday. Now, what I plan to do is I plan to go to Simulink today. So for the ones who are new to Simulink, the Simulink tab is there in the toolchain tool strip itself. You click on Simulink, you open the blank model. So whatever you make in Simulink is a model, right? So that's why you open a blank model and you can see this is how the canvas of Simulink looks like. Now, as I mentioned, it has a built-in library block. So if you click on the library browser, that's where you can see the built-in library blocks. Let's just go to the commonly used blocks. So these are some of the commonly used blocks. If you're working on some mathematical operations, you can go and click on maths operations and make use of the maths library or the mathematical blocks. If you are working on the logical operations, that's where the logical library is there. For every sort of a system, you need an input and an output. So that's where you make use of the sources library and the sync library. We'll be using these in our demo. Apart from the fundamental Simulink library, there are other libraries as well, depending upon what toolboxes or what sort of application area you are working on. You can probably click or use at one of those applications. For example, in this case, if I'm working on something related to an image processing application, I can click on the computer vision toolbox library, and that's where the entire block sets are available, right? So if I talk about the present application where I'm trying to invert an image, so first thing that I need is one image. So that's where I need a source. So I go to the source from the computer vision toolbox library, right? And that's where I can click on the image from file. If you have a file which is outside from MATLAB and if you have external file, you can also bring that file into the workspace and click on image from workspace. You can also bring a multimedia file, right? So what I'll do is I'll bring this file here. I'll use the image from file. Now, once I have that, what I want to do is I want to view that file. So that's where we will go to the same toolbox and go to the sync instead. Now in sync, we have something called as the video viewer. That's where we can view our image. So what I'm doing is I'm dragging and dropping the blocks, right? Now the ones who are aware of the algorithm used in image inversion. So what happens in an image inversion application is all the RGB components are subtracted from 255 because the RGB pixel values, they range from 0 to 255 because it's a unsigned integer 8-bit. So that's why we subtract to invert the image. To invert the image, we subtract all the three components from 255. Now, what we see in this case is just one output, but we need three different signals coming out of it. So I double click on the block. I go to the image signal. From one multidimensional, I can click on separate color signals. So that will give me the RGB components. I click on OK. Now what I have is the RGB components. Similarly, if I want to view that, I will go on the video viewer. In that, I will click on the file and separate the color signals. So now I can just simply attach these signals. But for my image inversion application, I need to subtract the RGB from 255. So what I'll do is, since I need to subtract, I will go to my maths library from Simulink, the maths operations, and there I will just drag and drop my add block. And since I need three subtractors, I will just copy these. Okay, what I'll do is I'll firstly change the sign. So if you double click on this, since you need subtraction also, you can change the list of signs. Now one of the blocks is addition, the other one is subtraction. Now R goes to the positive one. This is how you drag and drop your signals and you connect the blocks. Now I can copy and paste these, right? And all the RG signals, sorry, it goes to the negative. Since we have to subtract from 255, all the RGB components goes to the negative input of the subtractor. What goes to the positive is 255. So that's where I need a constant block with the value of 255. I go to the commonly used blocks and I drag and drop the constant block. Now that constant block's value is 255, right? And I also may need to change the data type, because if you know MATLAB, by default, the type of data is double. But in this case, we have the unsigned 8-bit integer. So I'll use that. And I'll connect the positive of these blocks with 255. So that's what I'm doing in this one. I just pause for a second. I'll quickly tell you what I did. I took the RGB components. I subtracted all these from 255. And the outputs are being fed to R, G, and B. That completes our application in MATLAB itself. So the same thing can be done on the online version as well. So if I run this one, so what you see is the inverted image coming up, right? Why? Because we just had one viewer and that's where we have put in the inverted image. If you put the viewer along with the input also, you can differentiate between the input and the output. So this is how Simulink works. This is how you can make a basic application in Simulink. Another thing what you can do is, for example, this is a very basic application where you have only simple equations or simple blocks. But if your application becomes complex, that's where there might be a clutter into your canvas. What you might want to do is create the systems out of it or the subsystems out of it. I can click on all the blocks and right click and mention create the subsystem from selection. So once you do that, you can rename this as image inversion. This is how a basic application of image inversion can be built with Simulink. Right? Now this is how I was running. This is here my run button, and that's how I can run my application. Now coming back to our thing about using it with the hardware. Now that's where I'll go back to the slide. I'll just quickly check if my screen and my audio is working fine. Seems like my screen is visible. I hope my audio works fine. Thanks, Dave. So I'll quickly jump back to my slides and I'll mention how we can make use of such application or how students can make use of this application and integrate it with the hardware. So what we saw in this case was we had this image, we had this model, this image was inverted and we could see the inverted image. Now, what we need to do is we need to understand how we can program MATLAB and Simulink with hardware. So there are two types of deployment that you can do with MATLAB and Simulink. One is where you deploy your entire algorithm into the hardware without writing a single line of code. What you have to do is simply make your model using the built-in library blocks, and then using the one-click code generation technique, you just make a standalone application. You have to deploy that code into the hardware. Another thing you can do is the real-time testing, where you can see the algorithm. So you can connect your hardware along with your laptop, along with your system where your MATLAB is installed, and you can keep changing your hardware position. For example, if it's a sensor, you can change the position of the accelerometer, and you can basically gather the real-time data from the hardware, and you can visualize that data into the tool itself, into the MATLAB itself, right? So real-time testing also can be done. But why program with hardware? It's a high level MATLAB language. You have specific functions. You don't need to write the code from scratch. Even if you're not comfortable with coding, you can make use of the built-in functions in MATLAB and built-in blocks in Simulink. Simulink has a block diagram approach. For example, I've been from an electronics and communication background. There are folks from mechanical background. There are folks from automotive, non-coding, where the students probably at times are not very much comfortable with coding. That's where they can make use of the block diagram approach. There's wide array of application-specific toolboxes. You don't have to write the code from scratch. You don't have to make the blocks from scratch. You can make use of the built-in blocks. There's a one-click code generation where the entire algorithm converts to the C++ code, and you can visualize that code also. And last but not the least, which is very important, it's an industry standard workflow. So the students, what we want from the students is when they are working in the academia, they should be having some knowledge of in the industry standard workflows and the tools so that they have a smooth transition to industries. So that's where they can start using MATLAB in their curriculum itself. And if it cannot be done in the curriculum, they can at least start building applications with MATLAB and Simulink. There are different hardware which are supported. I will also show, apart from these existing ones which are on the slide presently, what different hardwares are there and how to get access to the hardware support packages. I will show that going forward. So what you see right now is MATLAB Simulink can be integrated with Arduino, Raspberry Pi, Android devices. If you are working on, Texas Instrument for the electrical folks, if you are working on power electronics based applications or motor control applications, you can make use of Texas Instruments boards as well. If somebody is working on antennas or, for HDL code generation, so MATLAB code or Simulink is not just the code generation is not for C++, but also the code can be converted to HDL code for FPGA targets. Now, how to get that support package? I'll show that in the tool itself also. But in your MATLAB tool strip itself, there is an option to go to the add-ons. And when you click on add-ons, that's where you get the hardware support package. Now, once the ones who have the access to the license, it's not something you have to separately purchase. The hardware support packages comes as a part of the tool. You just have to go and install it separately. Right? What I'll do is I'll quickly switch back to MATLAB and I'll show you where this thing is available. So when you are on the MATLAB window, you can simply click on the add-ons and click on the Get Hardware Support package. This would need the internet. So when you click on this, you can see there are 300 plus hardware which are supported. Be it Arduino, the cameras, Raspberry Pi, if you're working on Android applications, so all these blocks, all these hardware are supported. Right? Now, what students can do is when they are presently working on a specific domain, and if they want to make an application out of it, you don't have to evaluate the entire code for them, because it's very difficult in this present scenario as well to evaluate each and every student's whatever sort of project or the code. For example, if they're lab experiments, it's very difficult to evaluate all of that individually, right? So in this case, what we also propose is you ask them to make application out of it, and then what you have to just evaluate is just see their results, what they are giving to you. Just observe the application, what they have developed. So going back to my presentation slide, this is how we go to the hardware support package. The one in this case is the Android. So what we will do is we'll install the hardware support package for Android. Once you install it, what you will see is a one-time configuration window where you have to configure your Android device with the tool. So that's just one-time step that you can do with the manage option, and this will give you the very good thing about this one is, so when I even get when I started with this particular approach, even I was new to it, and there's no training or nothing, even the webinars or the videos are not needed. This entire window in itself is very much self-explanatory. It gives you each and every step on how to and what to install, and what are the different steps involved in that for the entire configuration. So it will give you the access to all to the documentation. And once you have installed or once you have configured your device also, at the end of it, it will also give you the access to the built-in applications or ready examples that you can reuse and get started, right? So what happens is when you install these hardware support packages, these are the new library blocks that you will start seeing in your Simulink. For example, in this case, what you see is an Android library where you have the access to your all the sensors in your Android device. So your Android device is, I would say, it's like a combination. It has the camera, it has audio input, it has all the sensors. So that's where it becomes very easy to get started with making an application with Android. The students, when they are at home present at such situation, right, if even if they don't have access to Raspberry Pi, Arduino, or any other low cost hardware, they do have Android devices. And what they can do is simply download this hardware support package and make use of all the sensors which are available in the Android, and make use of the camera, make use of audio, and then make applications with that, right? And these block sets are available, which comes as a part of the support package. What you see on this side is the audio and the video, where you can use the camera or the basically the camera of your Android device, and it will capture that image and brings that to your tool. So what would change? I would probably, if this was a webinar or if this was a session in person, I would have asked what would change in this particular application. Now, if you see, our algorithm remains the same. Even if you're talking about image inversion or any other application, whatever we have simulated in the software, that's what we want to take to the hardware as well. So our application, our algorithm remains the same. What will change is the input and the output. The interfaces would change. Now, in this case, our input and output are being replaced with the Android library. So we have taken the Android camera from the Android library, and we have taken the Android viewer. What this would enable us to do is capture the image from the Android device, put the algorithm that we designed, and then view that particular output in the Android device itself. So once you have done this, once you have made the model, one thing that you need to do is do some settings. Now that configuration settings are important to be done because there are multiple hardware which are supported, and you may have to select the one that you are using currently in your application. Now, as you can see on my screen, since I've installed Raspberry Pi, Arduino, and TI hardware support package also, but I'll just select which which Android device I have, and then basically do the configuration of it. Once it is done, now once this configuration is done, the only step which is left is to click on deploy to hardware. That's the last step. So if you see on your tool strip in Simulink, there would be an option to click on deploy to hardware. Once you click on that, with one click, it would automatically generate the code, deploy that to your Android, and the application would start to run as well. So this is what we call as the one-click code generation, where in one click, You build, you load, and you run. So by building means you are generating the C code or whatever the target specific code is. Load means you are deploying that code onto the hardware. Run means you are also running the application on that. So that all these things happens with one-click code generation. And what you get as the end result is this sort of an application which I was running earlier also. So this view will come onto your Android device because I use the Android viewer. If you had multiple Android viewers, you will have multiple views, right? Another application which I can also show here is the edge detection. Now, what's happening in this one? Whatever is being captured. So again, the approach is same. You just need to change the hardware. The students may use another hardware. The algorithm will change, depends upon what application they are making. So the earlier one was image inversion. This one is edge detection, in which what's happening is whatever is being captured, edges are being captured out of it. And with this slider, what I'm doing is I'm trying to control the brightness, right? So I just played this video as well. So whatever is being captured. So what I've done in this one is I've used two filters, the Prewitt and the Sobel. So for the ones who are from this domain, for example, if somebody is working on signal and image processing, you know what these filters are, the Prewitt and the Sobel filters. These are all mathematical equations at the back end of it. So if you are aware of these, if you know the dynamics, if you know the equation, you can build it from scratch. But if you're not from this background, these blocks are available as a part of the library only. You just need to put these blocks, put the input and the output, and start building your application, right? So here what is happening is one is for the Prewitt filter and two is for the Sobel filter. So presently the selection is one. What I'm doing is I'm changing the brightness. So what you can see is the brightness is controlled. I can go about and change my filter. I'll change it to 2. That's the Sobel filter. Now you can see the view is also changed. This is how you can make an application and deploy it to your Android device. And the students, what they can do is either they can present this application directly to you, or what they can do is this becomes a .apk file that they can share with you. And you can just simply put that APK file into your Android device and start running the application. And you can see what the students have built out of that. So this is the model for that. If anybody is interested on having this example, you can get in touch with us. Just in the interest of time, I won't open this one, but I can quickly give an overview. What's happening in this one is, again, as you see, there is one input, which is the camera, and you have the output where your detect edges which are being detected are being displayed onto your Android device. Another thing what we have done is we used the controls. For example, we use the numerical control. We use the slider as well. So numerical control can be used to change the type of filter, and slider is where you're trying to control the brightness. Now these comes as a part of the library blocks only. What you have to build is this algorithm. So you just have to build these algorithms, click on the one-click code generation thing and deploy it to the hardware. So what happens is you have to connect your Android device using the USB cable, click on the deploy to hardware, and it will start building and loading the code coming out of it into the Android device. Now, another thing what can also be done is, so far what I showed was basically a standalone application. Another thing that can also be done is real-time capturing the data. So what we are showcasing in this example is using one of our Android's sensors. For example, in this case, I'm using the accelerometer. So this is the accelerometer with the 3-axis X, Y, Z. Right? This again comes as a part of the library. Now I'm capturing those signals and then basically putting a filter on top of it and viewing the signal. What happens is, in this case, we will be using the external mode. So if you might have noticed in the previous one, probably I didn't mention that. I will just quickly go back and show. In this case, what you would have seen for a standalone deployment, is a normal mode. So normal mode would mean it will simply build, load, and deploy it to that. But what you see in the other one is an external mode. So external mode basically enables you to change the parameters while your application is running onto the hardware. So I will be bringing one of the examples for this in the next demo, how you can, I'll deep dive into this one. But what I want to highlight is the external mode. Now what it enables you to do is connect your Android device with your tool, with your laptop. And then, for example, in this case, if I'm having the accelerometer, I will move my phone. So if you see in this video, while my Android device was connected with the tool, I was moving my phone up and down and the sensor data was being captured. Now this was being captured in the real time because I just made the video. So that's why you cannot see it in this point, at this point, but this is the real time capturing of a sensor data. Now, once you have that real time sensor data, you can just simply put your application on top of it and then deploy it to the hardware again. Another thing is, this is with Simulink. If you are working on MATLAB applications also, it's not always Simulink algorithms can be taken to the hardware. Even if you're working on MATLAB, what you need to do is, because in that case, you won't have the access to the Simulink library blocks. So what happens is, there is an application called as MATLAB Mobile. So once you have used if you're using the licensed version of MATLAB, what you also get an access to is the MATLAB Mobile. This is available in the App Store and it's in the Google Play as well. So what it has is, it has a view where it looks like MATLAB only, where you can write the script, do the visualization. It's the same view, but what you can also do with the MATLAB mobile is it gives you the access to all the sensors in your platform. So if you are having whatever sensors are there in your mobile device, you will get the access to that. So for example, if you see this short video, this is how the look of MATLAB mobile is. If you click on commands, you can go and click on sensors. So once you click on sensors, you get the access to the multiple sensors. Now these multiple sensors are from your device. So whenever you're moving, these data is being captured. Once your mobile MATLAB mobile is configured with your tool, what you just need to do is click on start sending, which is at the bottom. So what you see in your app would be a start sending. This would get enabled once your MATLAB mobile is logged with your or connected with your tool, MATLAB tool. You just need to start sending the data and it will start to send the real-time data and put it into the MATLAB. What you can also do is, since MATLAB online is also there, you can simply go to MATLAB online and start to log the data and put it in the MATLAB drive, right? So this is so far what I wanted to discuss on Android. The next thing is possibly I'll be talking about the Arduino one, how to integrate Simulink applications with Arduino. Again, the workflow would remain the same, but what we'll try to do is make a different sort of application and also try to use a different sort of tool, which is available with MATLAB. That's called as the Stateflow. But before I move to that, and the third thing which I want to cover after this is how to make IoT or using ThingSpeak platform, how to make the cloud-based applications. Before I move ahead, I'll just quickly do the check again with my team if the screen and the audio is working fine. So I can see my screen. Is audio clear? Sure. Thank you so much for letting me know. So in the interest of time, I'll move ahead. I'll quickly show you how you can make similar sort of applications without writing a single line of code with MATLAB, Simulink, and deploy to Arduino. So this is the Arduino kit that we are using in this particular demo. Again, in this one, I'll just try to highlight the external mode again. As I mentioned earlier, the Simulink support package for Android. Similarly, there's a support package for Arduino. Right? Again, you have to go to the add-ons, install the hardware support package, and then this library is what you get the access to. Probably just give me a second. I think I should be showcasing the library to you. That would give a better view. So I have this library opened. So what you see in this one, this is the Android library which I was talking about. So what you see is the audio video, the communication. If you're working on, if you're trying to connect it without the wire, if you're doing the wireless connection, you can make use of the TCP/IP receive send blocks. And think, speak, read, and write is something which I'll be talking about after this one. That's where you can make use of these block sets to make the cloud-based applications as well. I have an example for that. These are all the sensors you have the access to and the interfaces, user interface. Similarly, if I come to Arduino and if I click on the common library, that's where you will see the analog digital inputs, analog digital output blocks. Now, the only job which is left in this case is, so the application you have to make on your own using Simulink, or even if your code is in MATLAB, you can bring that to Simulink environment, which I will be showcasing in my IoT application. But apart from that, what you can also do is, so the only thing that you have to do is configure your particular pin number of Arduino, and just put the pin number into your blocks. So if you see this analog input block, it is asking only for the pin number. You have to mention which, at what pin is that analog device connected, right? So this is how the block looks like. I'll come to that. I'll just go to the slides. Now, what we are doing in this case is an application where we are making a temperature control sort of a system. It's a very fundamental application, and how the students can make it. So that's why we are keeping it simple, how the students can make use of this sort of approach and build application and deploy to the hardware. So what we are doing in this case is there are 4 different states, right? Either nothing is happening, or this just the fan is turned on, or just the AC is turned on, depending upon what the temperature of the room is. Or if the temperature exceeds a higher value, in that case, the alarm is turned on. So if the temperature is between 70 and 120, only fan. If 120 and 160, that's where only AC is turned on. And if the temperature exceeds 160, that's where the alarm starts to blink, or basically the LED starts to blink. Now, how such an application, so what we call such applications is, we also call them as decision logics. Why decision logics? Because what we are trying to do is, we are trying to make a decision on the basis of our actions, or based on the basis of an input. In this system, our input is a temperature. On the basis of the conditions of that temperature, we are having different actions. Either we don't do anything, or we turn on the fan, or AC, or alarm, right? So this is what we call as decision-based logic or an event-based logic. So whenever the temperature exceeds this value, an event is raised. On that event, we have to take a decision. That's where a tool called as Stateflow is used. Now that Stateflow, now this again comes as a part of Simulink. Before I come to the tool, I just want to give, I would just want to tell, maybe it's not a story, but just it comes from the experience, how, because prior to MathWorks, I was working in an automotive company, and I was not into programming, not C programming, not C++, Java programming, nothing. But I was actually expected to make similar applications what other team members were also making, right? So that's where the tools like Simulink and Stateflow came handy, and I could actually make those applications, same applications, and then with lesser time, lesser, I would say, I didn't have to learn programming. I could just make the model with the built-in blocks, make the logics and Stateflow, and with one-click code generation, I was making the same applications. Similarly, we have been working with other universities for usage of Simulink and Stateflow in first year itself. So we do have, experience from universities where they are making use of Simulink and Stateflow in the first year itself. The students are able to make such projects. They are able to integrate hardware without doing coding from the first year itself, because in first year, it's not just the coding perspective that we want to tell them. It's also the problem, how to solve a problem, how to make use of the different tools to make do that. So that's where we have been working, and it's quite an interesting tool. I'll briefly talk about that. But before again I go to this, I just want to quickly have a look at the chat window if there are questions. Although I have my team along with us, um, I'm sure they're taking care of the questions. But again, if there are any questions, you can please feel free to write the question in the chat window. Um, so yeah, I see a few of the questions are being answered. But still, if there are any questions, please feel free to write the question in the chat window again. Yeah, I could see Nikhil responding to the questions. Thanks, Nikhil. I'll go back to my slide and see how we can make this. Okay, now I have to make this particular application. Now what I will do is, rather than showing it in the slides, I will quickly show you how to make that in the tool, right? I will open a new model. Now, as I mentioned, the tool's name is Stateflow. I click on the library browser. If I go down, there is a toolbox called as Stateflow, and that's where a block called as chart is available. I'll drag and drop the chart, right? So I will double click on this one. I'll have this view. Now, what the Stateflow has, it has states, it has transitions. So if I see in my application, what I'll do is I'll just try to align these together in the view. Now, what I need is I have 4 states, but let's make a simple application with just 2 states. I'll make use of the 2 states in this one. Now, this question mark means you have to enter the name of the state. So my first state name is no action. Make sure there's no space in between. So that's my first state. My next state is the fan. I'll click on this and name the state as fan on. Now these are just the names. Now what's happening in no action is, in my system I have 3 outputs, which is a variable named fan, a variable named AC, and a variable named alarm, right? And in this one, there's no action, so fan remains off, AC remains off, and the alarm is also off, right? Now it doesn't always have to be a binary one. In this case, we are simply using a digital output, but if your application has an analog one, you can also use the integer numbers here. Now in fan on, what will happen is all these outputs, I'll just try to copy paste it. What happens in the fan on state is, so I'm defining my actions in my state. In my fan state, the fan would turn on, right? So in my no action, nothing is on. In my fan on, the fan is turned on. Now, if you see, there are some transitions coming, right? Either you select one of these, or what you can do is simply go to Stateflow, drag and drop an arrow. It will give you these 3 choices. In this case, I have a condition of temperature. I click on temperature. My temperature is between 70 and 120. So I will write temperature is more than 70 and temperature is less than 120. I just simply have to write this statement. Similarly, I can write a statement back, which would mean when I have to come back from this state to the next state, I can simply write temperature is less than 70. When temperature is more than 70, the fan is turned on. When temperature is less than 70, the fan is turned off, and other things are also off. This is how you make the state flow, the states chart. So what you do is, when you have to, now if you come back, you will see there are no ports yet. But to create the ports, what I'll do is I'll simply click on run button. Now that's the easy way to do. Just click on the run button, it gives you an error. Along with the error, it shows you a window where it automatically detects what is input and what is output. Now temperature is the input and rest 3 are output. I select that, I come back, and that's where my ports are. Now you simply, again, you're back to your Simulink view. You need to connect a constant block, which is your value of temperature, and you need to connect the outputs here. That's it, right? So what I'll do is, rather than spending more time on this, I'll show you the actual application which is inbuilt, which is ready to show. So this is how the entire chart looks like. Another thing you can notice, in case of alarm, what you will see is, because the LED blinks, so that's why you can make a state inside a state also, where one of the state is alarm off, and after 2 seconds it's turned on. So that's how the blinking happens at the rate of 2 seconds, right? Now what I'll do is, I'll show you how the simulation runs in this case. I'll do one thing. I'll open this in a new window. I'll put the views parallel to each other so that you can see, I would say, the actual beauty of this tool. So how you can make this application. If I run this or at the temperature of 80, if you remember, if the temperature is more than 70, the fan is turned on. So you would see this signal coming. It goes from no action to a fan on. If the temperature exceeds 160, at that point it's staying at the AC on. If it exceeds 160, it becomes 168 something. You can see the blinking is happening. So that's how you can observe the application and the algorithm as well, right? Now coming back to our hardware part. So this is where I was showcasing how you can make an application. So application, for example, if it's a temperature control or any sort of decision based application, even if you don't have the knowledge of coding, how you can do it with Stateflow. So what you have in Stateflow is, you have transitions, you have states. Inside the states, what you write is the action, and there are arrows which are basically your transition. That's where you write the condition, on what condition you are going from one state to another, right? I'll go to the next one. Now let's see how you can do it with Arduino. If the students are supposed to do it with Arduino, how they can do it. Simply, they need to install the Arduino support package, and from the Arduino support package, they need, because in this case we are using the binary output, so they can make use of the digital output blocks from the library. So I've taken the digital outputs, I've mentioned the pin numbers, I configured my settings, I went to the configuration settings, and I selected the Arduino board which I have. Now this is the end result. Now what you will observe in this video is, now this is running in the external mode, which I mentioned that you can do the real-time signals checking as well. So I will change the value from the tool, and you would see the result inside the tool and also on the hardware. So when the temperature is 40, there is no action. Even none of the LED is blinking. If I go and change the temperature, 80, you see the fan is turned on in the application, in the tool itself, and also the LED will start to glow. My third approach, my third test case would be, if I change the temperature, make it 180, now you see the blinking is happening. Now the blinking is happening in the software, and the blinking would also happen in the hardware as well. So this is how the students, using low cost hardware and using Simulink, Stateflow and MATLAB, they can integrate and make applications. And what they can present to you is such videos where they can see, where you can evaluate what sort of project the student has built. Another thing, I've also there are different support packages available, as I mentioned, for Raspberry Pi as well. So if somebody is working on Raspberry Pi, they can make use of the Raspberry Pi block sets and the existing libraries from Simulink to deploy the application. Now, coming to an application where we'll demonstrate, I know these are a lot of applications we are showcasing, but these are very simple ones. Anytime, please feel free to reach out to us. These are all documentation examples. These are all available online. If you are working on any sort of application, you can get in touch with us. We can share the links with you. Even post this webinar, we'll be sharing a link with you where that is the feedback form. But once you complete that feedback form, you will get access to all these all these models. So I've saved these models into our folder, and you will get access to all these demos along with the presentation slide, right? So you can get started with it. What I want to show now is how you can make an IoT-based application. What we are doing in this example is making a human activity recognition system. Now, this human activity, I won't get into the depth of this demo because this demo makes use of the AI applications, the machine learning workflows as well. But I'll just quickly walk you through what is happening in the demo. But what I want to focus on is how you can make basically a cloud-based application with MATLAB and Simulink. That's what our focus for now is, right? So what you see in this one, rather than showing in this slide itself, I'll open the model. This is how a model has been built for an IoT based application. So what you would observe is this is the Android accelerometer, again the same block. What we have done in this case is there is a person who is carrying an Android device and it's attached to one of the body parts, and then he is moving, right? And while he is moving, he is involved in multiple activities like standing, sitting, walking upstairs, running, laying down. So he's involved in these activities. And what is happening is we have used the existing data to train a classification model, the ones who are aware of the terminologies used in AI applications. So we have used the existing training data to make a classification model and use that model to classify the activities, right? So using this model, I deployed this model to my Android device, and I would show the end result first. What I came with the result, so my end result was this is again an Android, my same phone, and in whatever activity I was involved, it is capturing that and it is telling whether I'm sitting, standing, if I'm running or walking. Along with this, what I also did was I was capturing my results and putting that to cloud. What you see on this right hand side is a screenshot taken from ThinkSpeak. I'll show what ThinkSpeak is. So ThinkSpeak is a IoT platform that works. So we work in collaboration with ThinkSpeak. What they give is whenever you log in with your MathWorks account there, you get some space into the cloud and you can make your application in MATLAB and simply deploy that using the built-in functions and the built-in blocks to the ThinkSpeak platform directly. So whatever I was doing, whatever results were coming onto my Android device were also being updated onto my, the channel which I selected for my application. So this is a very good approach for these situation like these, where if you are checking your students' performance and if you want them to make an application and if you want to see their results, if not in the form of a hardware videos, what you can also ask them to do is make cloud-based application and share that channel with you so that you can see what results they are getting, right? Before I go to the demo, I will quickly show you how this ThinkSpeak thing works. I'll simply go to a new tab. I'll start to type ThinkSpeak. So that will take you to my existing channel. So whenever you open ThinkSpeak, so you see this is a platform. where you can integrate so you can capture the sensors from your hardware, uh, build algorithm in MATLAB, right? And take the results to the cloud. Similarly, what you can also do is take the data from the cloud, do the processing on top of it, and send it back to your edges. That is where your hardware is. So this works in a cyclic approach, right? So what happens when you open ThinkSpeak is if you have a MathWorks account, you can simply log in with that account. I will just enter my password. Now what you will see is the ThinkSpeak view where you can do the channel selection and put your algorithms as well. So by the time this thing opens, it's taking some time. I'll just quickly take back you to the demo and show you once this thing is opened. So this is what we were doing. We have our Simulink model where I use the accelerometer. That's again my Android device, right? I'm capturing my accelerometer signals. I'm calibrating that data. If you see, these are all MATLAB functions. What another thing I want to highlight here is if you are using MATLAB before and if you are not planning to work on Simulink so far, but you want to bring your MATLAB functions into Simulink, that can be done with something called as a MATLAB function. So these MATLAB functions, for example, if I click on one of these, if I click on this one, it will take me to the MATLAB function that can be brought to Simulink, right? Now, if I come back, my activities, which are after so what happens is once you capture your raw signal data, you calibrate that raw signals. On top of the raw signal, you put some mathematical operation. That's what happens in a machine learning workflow. You put some mathematical signal processing operations onto your raw data, and from that, you basically extract the features, right? Now, those features can depend upon what sort of application you're making. Now, in this case, we are showcasing only the sensor data. This can be audio or video as well. On top of that, then you make a classification model and you use that classification model to put in the predict activity and you predict the activities on the unknown data, right? Now these activities are being displayed one to my Android device. So this one is from the Android library, right? Another thing which I'm doing is I'm taking my results. So my results I'm taking to the ThinkSpeak as well. So whenever I'm talking about the hardware support package, as I mentioned in the communication, there's something called as ThinkSpeak Write. Now, ThinkSpeak Write would mean you have to just make your application in MATLAB and Simulink. Using ThinkSpeak Write, you can deploy that result onto the cloud platform. So you can deploy the results on ThinkSpeak. What it will ask you to do is, for example, if I double click on this, it will firstly ask for your channel ID. Now let's just see if this thing has opened. Okay, there is some issue with this one. I'll just probably try to sign in again one last time. Okay, now it's signed in. So what happens is when you come onto ThinkSpeak, you have to firstly create a channel, right? So you will have your channel ID. This is what your channel ID is. Similarly, if you see this one, these are my results. This is again for the human activity recognition demo. So my mobile phone, my Android device is not working from the last few days, so it's in a dead state. That's why it hasn't logged any data. But whenever I'll switch it on, I'll start moving, the data will start to come here, my accelerometer data and the predicted activity, right? So whenever you create an account on ThinkSpeak, you get the access to space and cloud. What you have to do is you have to start by creating a channel. You will get a channel ID, and along with that, you can also create the access of that channel as private or public. Now, in this case, it's private. I can only see that. What you can also do is, if you go to the API keys, That's where you will see the read and the write API keys. Now, if I go back to my Simulink model, that's where the block was asking for the channel ID and the write API key. And I can also mention number of fields. How many outputs do I want to see on cloud, right? And once we do that, then the last thing, once we have configured our write block, you just need to simply run the model. Once you run the model, whatever data is being captured from your Android device, which is in your pocket, the data will start to go onto the cloud as well. Similarly, if you are working on an application where you want to access the data from the cloud, that's where you can make use of the ThinkSpeak read blocks. And in the read blocks, you will make use of the read API. That will give you the access to read the data from the cloud. So this is the view for ThinkSpeak. You have to go to, for IoT-based projects, you can make use of this platform. Click on channels. Another good thing about ThinkSpeak also is because we work in collaboration with them, so you also can see a space for your MATLAB code. So whenever you are, it's not like you always have to write your algorithm in MATLAB and only deploy the results on the cloud. It also gives you some space in the cloud to put your MATLAB code. So some sort of processing, signal processing can also be done on the cloud itself. So for example, if I have to create a new channel, I can click on the new channel. I can name that test channel for VIT if I mention. I can mention the fields, wherever I want to get a link to, I can save the channel. So when we save the channel, now we have a channel created. We have a new ID related to it. And this is a blank chart. What I can also do is I can add visualization. So these are all MATLAB visualization. If you want to click on MATLAB analysis, you can actually get started with the MATLAB examples on ThinkSpeak itself. So there are some examples which are available. If you could just click on that, it will take you to those examples, which are built-in examples, and you can get started with that. So this is still opening. There's one example on displaying the humidity, the temperature, and there are multiple other examples. Right? So I'll just quickly go back to the streaming. I hope my video and audio is clear. Sure. So yeah, I will end the session by 3:30. This was the last thing I wanted to cover. Before I move ahead, I'm coming back to the slides. Right. So if anybody again, if somebody works planning to work on IoT-based applications, please feel free to get in touch with us. Apart from that, we want to share this story. Probably this might have been shared yesterday also, how our team worked with Manipal Institute as well. This is a published story, but we have many other stories also available, how we worked on integrating MATLAB Simulink into the curriculum. And this is one of the stories where they started to use MATLAB for problem solving in the first year itself. This is what I've been talking about. This is from that where the students, now if you see, these are all first year students. These first year students are making line follower robot or such applications using Simulink and Stateflow without the prior knowledge of coding and everything, but just trying to solve the problem, right? This is just to give an overview that we do have support for student competition. So if there is someone who is a faculty coordinator for a student competition team, you can also get in touch with us for more details. We do have a mini drone competition. There are multiple automotive competitions that we also support. So to get started, probably this might also have been shared yesterday. I know this the time frame, and without having a hands-on, it doesn't give that much of an experience on what the tools capabilities are. So if you don't have the access to the license, the best thing you can do is just get started with on-ramps. On-ramps are the free trainings. Great thing which we have now apart from these on-ramps. So as you might have seen the MATLAB online yesterday, that's the online version of the tool. So if at present situation, if you're not able to use the tool itself, and if you have the MathWorks account, you can simply go to MATLAB online, which doesn't need any installation or downloading, and you can access it anywhere. The best thing that we have for this year is the Simulink Online. So this got released last week itself. So it's not just MATLAB which is online now. The Simulink Online is also available. The online training on Simulink, which is called as the Simulink On Ramp, that's a free 2 hours of training. You don't need the access to the tool. You just need your laptop, your system, and you can get started with this online 2 hours, 2 to 3 hours of online training on Simulink Online. You don't have to install anything. These are some of the resources, some of the existing courseware, how MATLAB and Simulink have been incorporated in the curriculum. MATLAB Grader also, that's for, this also might have been discussed yesterday, that's for auto evaluation of the MATLAB code. If you're working or if you're giving assignments to the students online, then that's where you can make use of MATLAB Grader to automatically evaluate the codes as well, MATLAB codes as well. Right, so these links would be shared with you, these presentation slides. That's why we have put in all the links at one page. You can get started with these. This is the last slide that I have. I would request all the participants to please scan this QR code and submit the feedback form. With this, what we get access to is your email addresses. That helps us to share more resources with you. And also you can get in touch with us to, if you have any concerns, if you're working on the online mode of education, if you're trying to take your classes to the online classroom, please feel free to get in touch with us. We'll be more than happy to work with you. So I would request you all to please scan this feedback form. And when you scan this, when you complete this feedback, what you will also get access to is all the document files that we have been showcasing today. So you can download it from that link. So after completing the feedback form, you can download that. So again, so that's it from my side. I'll try to put this, if possible, I'll just try to put this feedback form link into the chat window so that it can be shared in the chat as well. Okay, I'm not sure if I can put that. So if anyone from the host team, if you can just please paste this link onto the live comments, then that would be really useful. I'll stop sharing the screen for now. And we have another 10 minutes. So if there are any questions, please feel free to write the questions in the chat window. I'll also take a look at it and I'll try to answer that verbally as well. Okay, there is a response from Professor Amrita. Thank you so much, ma'am. So ma'am says that she has been using ThinkSpeak for IoT Lab. If you come across more application areas for it, please feel free to get in touch with us. We'll be happy to share more resources with you, ma'am. So once you complete this feedback form, you will get the access to the documents as well, whatever we have used today, and the presentation slide also.
I would like to thank all our speakers on their various inputs. It has truly been a very interesting and interactive session. We are getting very positive reply from our participants. Thank you for explaining the MATLAB and Simulink application in the simplest manner. All queries were being answered by Mr. Nikhil Sonawne. Thank you, Mr. Nikhil. On behalf of entire first year fraternity and on my very own behalf, I extend a very hearty vote of thanks to Ms. Naini Dawar and Mr. Debanand Singhdev for sharing with us your opinions. Thank you, madam. Thank you, sir. Now towards the end, today we have representative from McGraw-Hill publication who wish to present on a variety of e-contents, e-books, videos, etc. They have requested us to allocate 15 minutes time slot in our FDP for the same. Just to make it very clear to everyone here in this platform, we do not have any collaboration with McGraw Hill in any way. We have communicated to them that it should not be a promotional event. We have permitted them to present only because they can suggest useful resources for the benefits of FDP participants. So, over to you.
Good afternoon, everyone. My name is Rahul, and I'm taking care of the entire digital stack for McGraw-Hill. I hope you can see my screen. Today, we will going to speak about different products which we have in McGraw-Hill. But before that, I would like to thank Ishan for this lovely introduction. Thank you very much. As he rightly said, we are not able here to showcase what we have, whereas we are here to showcase those things. Like technology is evolving every day. Whatever there is we have in technology can be leveraged by different faculty members, end users, students. So with that aspect, I would like to set up a context of this discussion so that you understand. In next 10-12 minutes, I would like to cover these set of technology products where we can transform the physical way of learning, teaching, etc. into an online mode. So the four key products which I would like to demonstrate are Connect, Express Library, SimNet, and New Interactions. So I'll quickly move on to Connect. This is one of the unique adaptive classroom-led learning platform which give emphasis on personalized learning. From the faculty standpoint, in a simple layman language, I would like to translate that whatever you do in a physical class can be replicated over an online platform. Example, student registration, then you prepare lectures which can be done through different instructor resources. Number three, you do assessments, like you give pre-reading assignments, post-reading assignments, you give assessment, quiz, tests, assignments, etc. for a stipulated time, and then you give extensions in your physical class. So all these parameters are associated and can be given through this platform. The beautiful feature of this and the USP of this platform is a smart book, which is very interactive, and it is built on artificial intelligence, which gives a fair understanding to a student under the personalized learning curvature. It means every student has a different learning style, so it adapts to the capability of a student learning and behaves, and the adaptive algorithm which is already inculcated in the platform responds accordingly. And at the end, a student can also measure his or her performance. On the other hand, the key aspect for the faculty members is all the pen and paper you use, and it takes time for you to create that content. It would be easy for you to just have this, and there would not be any requirement of a pen and paper, both for faculty members as well as for the students. Lastly, there are robust analytics associated. Nowadays, you just put that grades on a sheet, and then you submit it to the respective audience. Here, it would be all automated. There would be assessment, automated graded on the quizzes, tests, subjective, objective, etc. So robust analytics are the key USP of this product. So that was Connect. Moving on to the Express library. Now, nowadays, or if I may say, it, in the era of COVID-19, most of the institutes, they are running after online programs, and they are doing their audio and video conferencing, and they are trying to give assets or the content like ebooks and other associated content through online means. In this product, we can also give ebooks to our students, which are highly adaptive in nature, and it works online, offline. It also works on a web browser. It also works on Android tabs, smartphones of iOS, and different tablets. Now it sits on AWS, so there is no there is no packet losses, and there is no internet connectivity as such required. Students can download this. It is DRM protected, and keeping our IPR policies in mind, we have created this construct for all the students and faculty members. Approximately, there are 1,800 books in Express Library, which can be availed as per the requirement, and can be given to students and faculty members in clusters, or maybe if any standalone ebook is required. In this product, faculty member or any of your students can highlight, can bookmark, can comment, can do whatever they wish to, and the book will respond in line to the feedback taken by the student. So that was Express Library. Quickly moving over to SimNet. This is one of its own kind, as this is a product from US, and it focuses on O365 and Microsoft Stack 2019. It gives a professional training to all the users, and it starts with the subscription-based model. It captures and capitalizes on all the key parameters of O365, covering Excel, PowerPoint, Word document, and any other associated program of Microsoft. And it will definitely add on a value of for a student while constructing a resume. And definitely there is a certificate associated which can be taken up by a particular student, and it will obviously leverage in near future while giving an interview or trying to have that competitive examinations. So that is SimNet in a short form. The last but not the least is New Interactions. This is one of its own kind in terms of English language learning. It's built on CEFR framework. So CEFR represents Common European Framework of Reference, and it's highly credible, and it's a framework which is highly recommendable in the Western countries. Now, as you can see, it starts off with a diagnostic test, where a student comes in and gives that diagnostic test, and based on that, it defines the respective CEFR level. Now, based that, a student will start off with their academic English, where the focus would be on the adjectives, nouns, preparations, etc. If I have to say, I would say it's an academic program constructed for curriculum-based learning. Now, having said, it comes up with a certificate as well, which is accredited by McGraw-Hill, and a student can avail that. Secondly, there is an adaptive feature again for the student understanding, as the learning outcome would be measured in LSWR, which is listening, speaking, writing, and reading. So it also sits on an open learning platform, which is very conducive for all these students under self-study, and also teachers can contribute, and they can also align their subject content in the form of case study articles, newspaper submission, or any other form for their students' pursuit. So it's emblematic for all the users, as it's adaptive, and students can learn themselves, and if required, teachers can also intervene, and they can also see the progress of the students. It comes in a hybrid model, where we give digital solutions along with some print books if required, and we can also give it or distribute it as per the institute request. So that was New Interactions. I would like to quickly jump over to Q&A if there is any. Over to you. Thank you. Am I audible?
Yes.
So my sales team members will definitely get in touch with you. Anirudh Kulkarni is one of my sales team member deployed in West. If you have any such requirement, please liaise up with the respective intellect. Thank you. Over to you, Ishan.
Yeah. Thank you.
Thank you.
Dear participants, please note below information about tomorrow's morning session. We have planned a session by Ms. Jenny Asher, Corporate Communication Association, Indian Institute of Digital Education, on the topic of creating e-content. As informed by them, they'll be conducting the session on Zoom. Participants are requested to separately register for tomorrow's morning session on the link sent to you. Once your registration is over, you will receive email confirmation from IIDE along with joining details. Participants will receive additional certificate for attending this session from IID along with certificate from VIT for overall FDP. All are requested to register on priority. Dear participants, if any participant wishes to share about any novel idea in preparation of an educational video, PPTs, storytelling, quiz, online resources which are not covered in the FDP so far, you are invited to share your knowledge in 2-minute video which you can upload on a drive link which we will share with you shortly. Selected videos will be compiled and shown in the FDP tomorrow. As we come to the end of FDP tomorrow, if anyone is interested in sharing their learning experience in this FDP, please respond on the Google form link, which we will share with you shortly. 5 participants will get a chance to share their experience during the FDP. Tomorrow afternoon session will be conducted by Ms. Ajita Deshmukh, Assistant Professor, School of Educational and Research, MIT, ADT University, Pune, on the topic use of H5P in creating interactive video. The session will be streamed live like all other sessions on YouTube. Thank you and see you tomorrow at 11 a.m.